So very good morning, students. So welcome to IIT NEET Foundation Program or Focus C by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 7th students for today's session. As you can see on the screen, and you are well aware, my subject is physics. We are in class 7th. Our ongoing chapter, that is chapter number 5, pressure. Today we are entering into the session number 2. So far we completed one session, that is in last class we started the new chapter pressure, 5th chapter from your material, and today we are entering into the second session. So we'll continue where we left in the last class. But before that, let us recall what we learned in the last session. So we started the chapter with a word thrust, right? Then we learn about what is pressure. Then we learn about what are the units of pressure. So many units are there in different systems, right? And a few example applications of pressure. Few applications where we can observe the pressure. Then just introduce about the liquid pressure, how pressure exerted by liquids. Some, right? So first thrust. Thrust is nothing but the force acting perpendicular. In a force acting on a body perpendicularly, for example, when you place a book on a table, right? So force acting downward direction perpendicularly at an angle of 90 degrees. Such a force is called thrust. And that force acting in a unit area, in a particular area, is called pressure. Pressure is nothing but force exerted, force acting on a body in an area. So area and force directly impact the pressure. We have seen so many examples why you are inserting the nail by painting the sharp edge towards the wall. Why not at the big edge? And how come the skaters will move on this ice with the skating this one? Similarly, why camel can walk easily on deserts than human being or any other donkey or horse? Because of the wide area is more, pressure is less. Area is less, pressure is more. Similarly, force also will affect. Force is more, pressure is more. Less force, less pressure, more force, more pressure. So pressure is directly or indirectly affected by two factors. One is force and other is area. So it is directly proportional to force and inversely proportional to area. So it is measured in Newton per meter square or dyne per centimeter square or Pascal, bar, torr, and atmospheric pressure. There are so many units are there for the pressure which are having the relation also. So there are so many examples we have seen applications. So how come the camel walks over the desert very fast or comfortably compared to the horse? Because the foot of the camel is very big and area is more. As area is more, pressure is less on the sand. Because of less pressure, it can travel comfortably. Whereas horse or donkey, if you take a human being, the area is of contact with the sand is less, so pressure is more. So our legs will go inside, pierce into the sand. So like that, we have seen few examples where we can find the applications of pressure. Of course, is also a pressure only, blood pressure. So we'll continue there where what we learned in the earlier class. So after knowing about the pressure is equal to thrust by area, and pressure is directly proportional to force and inversely proportional to area of cross section. Okay, up to that we learned. And of course, we have seen some examples here also. Then pressure in fluid. So all right, fluid is nothing but which flow. Suppose when you keep a pen on table, it will remain there only. It won't move forward. But same time, when you drop some water on floor or drop some any gas also, they flow. And that's why they're together. Gas and liquid, liquids and gas together called fluid. What do you call it? Very, very big chapter is this. In higher class also you come across fluid. So see, a substance which can flow from one point to another point is called fluid. Some liquids and gases can flow, so they are known as fluids. A fluid exerts three types of pressure. One is downward pressure, upward pressure, lateral pressure. Okay. So downward pressure means pressure acting in downward direction. So suppose when you open the tap, water is coming down. Why? Because of the downward pressure of liquid from the tank. When you throw some rubber ball into the water tub, it will come back because of the upward pressure. That is called upthrust. And full the any plastic bottle full of water and make one hole at the one side. We can see how it will come out. That is called lateral pressure. From side osmosis, it will exert the pressure on all directions. Liquid exert pressure in all directions, either upward, downward, or lateral pressure. See, upward pressure is very important here. Because of the that is called upward pressure of the liquid is also called as upthrust. Okay. So you can see the mathematical expression for pressure in liquids. So consider a vessel containing the liquid of density D and a coin of area of cross section A. We drop the coin. Place in a bottom. We place one coin at the bottom. A liquid column height H and area of cross section A forms an imaginary cylinder above the coin. This column exerts its weight on the coin, giving rise to the liquid pressure. When you place the water coin at the bottom, it exerts pressure. So from that, volume of the imaginary liquid column, volume is equal to. So volume is nothing but length into breadth into area. Right? Height. Length into breadth into height. But what is length into breadth? It is nothing but area. Area into height. Suppose I get capital letter, I took small. So how you got area into height? Because volume is nothing but length into breadth into height. So length into breadth you can write as area. Area into height is the volume. Formula we got, right? Mass of the liquid column. So what is mass? Density is equal to mass by volume. So mass is equal to volume into density. Right? So what becomes mass is equal to volume? What is volume? A into H into T. That's what we're given here. Mass. Then weight of the liquid column is equal to mass into volume due to gravity. So what is weight? M into G. We have already seen mass into gravity. So you can give what is mass here? W is equal to, in place of mass, you can write A into H into D into G. Right? Correct. So A into H into D into G we got it. That is the weight of the body. So what is pressure? Thrust by area. Force by area, thrust by area. So thrust is nothing but weight only. Weight is nothing but thrust. So pressure is equal to A, H, D, G by area. So area cancel. So P is equal to HdG is the formula. Mathematical expression for the pressure of liquid. Simple. We are dropping coin into the liquid. So what weight, what pressure exert on the liquid is given with the formula. That is HdG, where H is the height from the bottom, how much height it is there, and D is the density of the water or liquid. G is the acceleration due to gravity. Clear? Is a mathematical expression for the pressure of liquids. Right? Now, loss of liquid pressure. Right? When liquid exert pressure, no doubt, when you are swimming also, the water when comes from the opposite direction, will get the force on you. Until unless you move your hand and leg, you cannot move forward. You'll go backward only. That's why we'll try to apply the weight on that and we'll push the water backside. Action and reaction. So liquid definitely exerts pressure. Okay. So law of liquid pressure. After seeing that, we can conclude some statement. But the pressure at a point inside the liquid increases with depth from the surface of the liquid. Right? As you are going inside, depth. As you go depth, pressure increases. P is equal to HdG. HdG. Formula is there. So as you go inside, depth. As depth increases, automatically the pressure increases. On surface, pressure is less. Surface of the water. When you go to deep, pressure increases. Pressure at a point inside the liquid at a given depth increases with increase in the density of liquid. So different liquids have different pressures because they have different densities. It depends on density also. So depth or height, one factor. Density is other factor. Pressure is same at all directions about given point within the liquid. Within the liquid, suppose only one liquid is there. Within the liquid, pressure is same in all directions. Very, very important law this is. Pressure is same in all directions within the liquid. If you go to other liquid, it may change. But in a given liquid, the pressure is always same. Pressure is same at all points in a horizontal plane at a given depth in a stationary liquid. Liquid is stable, not moving. Then the pressure is same on the entire surface, horizontal surface, at any point. So a liquid seeks its own level. So the level, which level it is there, the level also is important. All these together, observations together called as laws of liquid pressure. What do you call? Laws of liquid pressure. So how the liquid pressure is exerted or used? As you go to the depth, as you go to the lateral distance, as you go to the height from the bottom, based on that all will come. Okay. So just before going for the next part about the atmospheric pressure, just I'll show you one video on the same.
Have you ever wondered why a large ship floats but a small pebble sinks? In this video, we'll learn about floating, sinking, pressure, and density. Density is a measure of how heavy something is relative to its size. It can be calculated using this equation. Try calculating the density of a wax candle that has a volume of 2 centimeters cubed and a mass of 1.9 grams. Pause the video to work it out. We can use density to predict whether an object will float or sink when it's placed in a liquid. If the object is more dense than the liquid, it will sink. If the object is less dense than the liquid, it will float. Water has a density of 1 gram per cubic centimeter. Will the wax candle with a density of 0.95 grams per centimeters cube float or sink in water? That's right, the density of the candle is less than the density of water, so it will float. Lead has a density of 11.3 grams per cubic centimeter, and liquid mercury has a density of 13.5 grams per cubic centimeter. What would happen if a block of lead were placed in a beaker of liquid mercury? Pause the video while you think. The lead would float in the liquid mercury. So that's a fairly easy way of explaining why solid blocks float or sink. There is another thing to consider: buoyancy force. All liquids are made up of particles that can slide over each other. When the particles collide, pressure is produced. The pressure in a liquid varies with depth and density and gravitational field strength. In a column of liquid, the water will pour out through the holes in the side of the container. The water that pours out of the hole at the bottom of the container travels further than the water that pours out of the hole at the top. This is because the water at the bottom of the container is under greater pressure than the water at the top. The mass of the particles pushing down on the water at the bottom of the container creates more pressure. The deeper the liquid, the greater the pressure. We can use these facts to derive the formula, where P equals pressure, ρ equals density, H equals depth, and G equals gravitational force. Imagine a cuboid submerged in a tank of liquid. The distance from the surface of the liquid to the bottom of the surface of the box is greater than the distance from the surface of the liquid to the top of the surface of the box. So H2 is bigger than H1. because P equals rho GH, the pressure on the bottom surface due to the liquid must be greater than the pressure on the top surface. This results in there being more force on the bottom surface of the box than there is on the top surface. The difference between these two forces cause there to be a net force upwards called the buoyancy force or upthrust. If the buoyancy force is greater than the weight of the object will rise up through the liquid. If the buoyancy force is less than the weight of the object will sink. If the buoyancy force is equal to the weight of the object will still float.
Partial. Very good information given, right? Very good information is given in the video, right? Then we'll go for atmospheric pressure. Pressure in atmosphere. You know, atmosphere is nothing but a thick blanket of air surrounding us. Surrounding the earth is called atmosphere. So whatever you are seeing, whatever our surrounding is there, everything is called atmosphere only. So it also exerts some pressure. The force exerted by atmosphere on unit area of the earth's surface is called atmospheric pressure, right? Whatever the surroundings are there, air, gases, dust particles, moisture, so many fog, so many things are there surrounding us, right? All these exert some pressure on the earth. Such pressure exerted by the surrounding on unit area of the earth is called atmospheric pressure. So standard atmospheric pressure. The standard pressure is the average pressure of the atmosphere at sea level, right? That is 273 Kelvin approximately, is expressed as 1 atmospheric pressure. 1 ATM we can call now 1 atmospheric pressure. Okay. It is found that 1 atmospheric pressure can be balance a column of mercury of 0.76 meter or 76 centimeter of Hg we can call it. Hg means mercury. Thus, the standard pressure is 0.76 meter of Hg. We cannot aware of because the blood in our body exerts the pressure which is slightly greater than the atmospheric pressure. So the pressure from outside and pressure from inside only balances the blood to stay back. If inside pressure increases, blood will come out, blood vomiting will come because of increasing the internal pressure. Slightly greater than the atmospheric pressure, okay. So we can express it in Pascal, right? That is called Hg, 0.76 meter or 76 centimeter or 760 millimeter or Pascal, right? That is called atmospheric pressure, the pressure exerted by the atmosphere on unit surface of the earth. So what is atmosphere? Whatever the blanket of air surrounding us is called atmosphere. Okay. If atmospheric pressure is P0, acting on a force of surface of liquid is also taken into the account, then the total pressure in the liquid of depth H is equal to same H rho G. So P is equal to, we know, HdG. Then when you consider the atmospheric pressure also should be added along with this liquid, not only this pressure, atmospheric pressure also will add. So you can write P0 plus HdG, the total pressure acting on liquid, because it is opened. When you place the liquid open surface, the pressure acting is given by H rho G plus even atmospheric pressure also acts on it. Right? So how to measure the atmospheric pressure is given simple. Simple method is there. The instrument used to measure the atmospheric pressure is called barometer. By using the barometer, you can measure the atmospheric pressure. It was constructed by Torricelli in the year 1963. Torricelli is the name. There is a name, a scientist. The liquid is used in the barometer is mercury. Just simple see. Here it filled with the mercury, and when test tube of uniform cross section is inserted, what we can see is because of the atmospheric pressure, the mercury level raises to 76 centimeter. This is 76 centimeter. Means whatever the pressure acting in a mercury here by atmosphere, because of that pressure, the liquid raised to 76 centimeter. By that you can understand the atmospheric pressure is 76 centimeter. By the simple way, based on this only, the principle only, barometer is designed. Right? So finally, we have wonderful formula. Transmission of pressure in liquid is proposed by Pascal, which is also called Pascal's law. Wonderful. Pascal's law states that the pressure exerted at any point in an enclosed and incompressible liquid is transmitted equal in all directions. Suppose blow a balloon or fill the balloon with water, right? It bulges and make holes in the various directions, various places, and hold it. We can see that pressure exerted same in all directions. That is a statement of Pascal's law. Pressure exerted on liquid in all directions with same, right? Equal in all directions. It is called as Pascal's law. Where it is applicable, you see. Right? That's simple. Pressure is called force by area only. There is no new formula for anything. Where this is applicable, you can see Pascal's law. The working of hydraulic machine. Hydraulic machine, where we use for the crushing the oil seeds. Oil seeds will be there. To crush the oil seeds and get the oil, we'll use the hydraulic machine where we use the water. Suppose when you go to the car wash station, your car will be placed in a pit. Will take it to the pit and pit, and they'll raise the car. How the car is raised with the machine? Because of the hydraulic pressure. And after raising, it's screened at the bottom, one lower level also is screened clearly. So car is lifted by hydraulic water pressure only. That is also example for the hydraulic machine. And there is another called Brahma press. That is also called Brahma press. And that is also uses the Pascal's law, where the pressure exerted by liquid is same in all directions, and use it to crush the oil seeds. Even cotton seeds are crushed to get the oil. Right? So where hydraulic press is used? It is used in the compressing the cotton seeds. You get the cotton oil. Used for the extracting the oil from the oil seeds. It is used for punching the holes in a metal. It is used for servicing the automobiles in the service station. And what happened is, by applying the less force, we'll get the more pressure. Because the area changes. First area is small, second area is more. Like that we'll do. Applying the less pressure at the larger area, we are getting more pressure from the smaller area. That is a process of designing the hydraulic machine, or is also called as Brahma press. What you can call Brahma press. You come across in higher classes the construction of working of this. So simple understanding is, as according to Pascal's law, the pressure exerted in a liquid is same in all directions or equally in all directions. Because all directions equally, we can raise the car to the required level for washing purpose. That is servicing. And also for crushing the cotton seeds, crushing the oil seeds, making holes to the metals. For all these purpose, this hydraulic machines are used, which works on the principle of Pascal's law. Clear? Very, very important one. Then later we'll come across, of course, another important laws are there in pressure chapter. But this is for the, so there are so many questions you can see here where we'll come across the questions related to entire chapter, where we started with what is pressure. Right. We started with what is pressure. When it comes to the first beginning, from the beginning, if you see, when you recall, this is a chapter, complete pressure chapter. So these are the topics what we covered. The first one is thrust and pressure. Right. Defining the thrust and pressure. So thrust is nothing but the force acting on a body perpendicularly. Force acting perpendicularly on a body. When any object is placed on table, then thrust acts on the table in the downward direction. That is called thrust. That particular thrust acting on a unit area, that area is called pressure. Force is equal to force by area or thrust by area. Means greater the area, lesser the pressure. Example, camel. Lesser the area, greater the pressure. Example, coin. When you drop the coin into the water or pebble, will shrink because of the less area. Right? So many examples are given here. Then applications. I've seen the camel can walk over the beach very comfortably compared to the horse or donkey. Why? Because the camel is having the more area, the foot is having more area. Similarly, skater. When you're skating on ice also, then use the skaters, use wide area one shoe, wide area shoe, so that they can skate easily or comfortably. Application. That is also another many more are there. Then pressure in liquids. So not only solids, liquids also exert pressure, right? So it may be downward pressure, upward pressure, or downward pressure, upward pressure, and lateral pressure. Laterally also they exert the pressure. But the pressure exerted by the liquids is same in all directions. Same in all directions. That is as per the Pascal's law. Pascal's law states that pressure exerted by liquid is same in all direction. Example I told already, just blow, fill the balloon with water and make holes at the different levels. From every level, we can find that the water is coming out with the same pressure. Okay. Then, after knowing about that, we have seen the loss of liquids and atmospheric pressure. The pressure exerted by atmosphere, which is measured by barometer, is measured by barometer, right? And the barometer is works with the make use of mercury. With the help of the using the mercury, barometer will work and the pressure will raise up to 76 centimeter or 0.76 meter or 760 millimeter of the Hg or mercury, atmospheric pressure. So when you are getting the pressure in a liquid, we have to consider the atmospheric pressure also. So the total pressure exerted by liquid is nothing but P0, that is atmospheric pressure, plus Hdg, which already define the mathematical derivation for the pressure. Clear? So this is a total topic, a small topic of pressure, which is discussed. And finally, Pascal's law and applications are very important. So this is the about pressure and the pressure in a liquid, right, fluid, and the mathematical, even fluid, gas also, if you see, in gas also exert pressure. Suppose when you are going by cycle, strong wind come towards your side. So you have to apply more force to overcome that pressure. Why? Because the air is exerting pressure on you. Even when you see the cricket also, when the bowlers are bowling, they'll see the direction of wind, in which direction wind is flowing. As per that, they have to bowl either speed bowling or spin bowling. The ball will swing. The spinning of ball also because of this only. That will come across later. They were Bernoulli's higher classes. So mathematical expression we have seen. Similarly, law of liquid pressures. There are 5 laws are there. Atmospheric pressure we discussed. Barometer we have seen. And finally, Pascal's law. The pressure exerted by liquid is same, equal in all directions. Right? So applications of Pascal's law is in case of the hydraulic machine. Hydro means water. A machine uses the water. Hydraulic, simple. For crushing the seeds, crushing the cotton seeds, oil seeds, or for servicing automobiles when you go to the servicing stations. Your car will take into the pit. And how car is raised because of the water pressure. Means water can exert the pressure, which also helps the car to lift to a certain height. Right? So this is totally about the pressure chapter. So when we meet in the next class, we'll start our next chapter. Heat, maybe heat. Okay. So this is about simple topic pressure and simple explanation is given. It's not a big chapter, very small chapter, right? So you practice everything, levels, all questions at home with the concept what we discussed and put it in the notebook and give your teacher for the correction, right? So thank you, students. Have a wonderful day. Thank you.